Hey everyone! Today's topic is about lateral surface area. So very related to total surface area, which we did yesterday, with one teeny tiny little difference, just related to this word lateral, and you're about to find out what it is. Here we go. All right, your objective today is to know the difference between lateral and total surface area. Right? Two different words, they have different meanings. You need to know which one is which. Also, you will be able to find the lateral surface area. This is actually something to calculate. So you have a definition objective as well as calculating something. All right, moving right along. Before we actually talk about lateral surface area, I've got a picture of a globe here. That's a globe. Yes, I don't know if how many of you, since y'all are pretty young, have actually seen a globe maybe in real life? I don't know if they even teach all this in social studies anymore, but maybe back in third or fourth grade, you were taught that on a globe there are two different type of lines. There are lines, as you can see in this picture, that go side to side or left to right, right? There we go. Those had a special name. The ones that went side to side were called latitude. Is this jogging your memory a little bit? And then there was a different name for the lines that go up and down. They were called all through the globe, they go up and down. These were called longitude. Latitude side to side and longitude up and down, right? Because the long lines, longitude, get that? Okay, so we don't really care about longitude, but if you focus on latitude, and lateral, wherever you see that LAT kind of thing, it means things that go side to side. And that's just going to give you a hint that lateral or latitude, or I'm trying to think, maybe it's coming to you that there are more words that sound like this, is a code word for sideways, we can say sideways, or left to right, or side to side. Okay, these are sort of hint words. My handwriting is terrible, but I hope you're understanding the gist of what I'm trying to say. I'm trying to give you code words. Okay, think sideways. Think of the lines on a globe that go sideways, and think side to side. So now let's get to our mathematical definition. Lateral surface area is the let's see, total of all the areas. Okay, it is the total of all of the areas of the surfaces of a solid, except for, and this part right here is important, except for the bases, right? This is a part that makes it different. The first part of that, the fact that it's just the total of all the areas, that sounds exactly like total surface area, which was just everything. But we are excluding something. We do not include the bases. By bases, a lot of the times we mean top and bottom, but not always. But that's a good clue to go by. Just write top and bottom also as an optional thing. All right, here on these pictures, we're going to label what the lateral surface areas are, or the bases, the things that we're not going to calculate, obviously. So on letter A, this is a triangular prism. Remember, on a triangular prism, no matter how it's positioned, the bases are always the triangles. So lateral surface area would be, we would find everything else, all of the sides except excluding, we do not find the bases, the top and the bottom. Okay, what we are going to calculate, I'll show that in a different color, are all the other sides in yellow. So you're just finding the sides basically. One way to think of it is that you're finding the area of just the sides, not top, bottom, not the bases. Okay, so same thing. Now for the remaining, On letter B, I'm going to shade the lateral surfaces. So that would be everything on the side, right? Not including, we do not want the bases, the top or the bottom. That I'm trying to show you through the box there that we don't want that bottom. So just the sides. All right, on letter C, again, we want the sides. That counts as lateral surface area. We do not want the two triangular bases. Also, if this was upright, it would be a top and a bottom. Remember the difference. Total surface area was everything. Lateral is leaving out possibly one or two of the sides. All right, on letter D, again, lateral surface area is all of the sides that go around except for, so we don't want the bases, most often also called the top and the bottom. But besides those two, you would find everything else and add it all up. We'll do examples and this will all kind of come together, but just for, introduction's sake, I'm showing you quite a few pictures here. Okay, letter E, lateral surface area is everything that goes around, not including the top and the bottom, or in this case, the bases. Same thing. Letter F, we don't want the two bases, but everything else you would find them separately, add it all up together. Okay, that's when, those are examples of when that's an actual solid shape, but what about nets? When we have nets, which actually in 7th grade you're going to be dealing with nets most often. So here's a net of a triangular prism. If you were finding the total surface area, you would find every single piece and add everything up and get your total. Remember, that was yesterday. Lateral surface area, though, is everything except for the two bases. So we do not want to include, or don't even need to find, the two triangular bases. If that net was folded up, it would form a triangular prism with two triangular bases. So lateral surface area is less work in a way. If you think about it, you don't have to worry about every single side. All right, on this cube net, remember, total, if the question asked you what is the total surface area, you would find every single piece or face, add it all up, and that gets you your total. However, lateral surface area tells you that you can leave out, you do not have to include the two bases. Now on a cube, does it really matter which one a base, which side is a base? Because a cube looks the same no matter what. Right? No matter which way you turn it, it's all the same. So basically you can just leave out two of the sides. Think of it that way. All right. Revisit this part of the video if you need to. It could be tricky in a way if you're so used to total surface area, but let's do some examples and I think this will make sense. All right, example number 1, find the lateral surface area of the figure below. This is a triangular prism. Right? If this was laid out, the net would look it would have a bunch of three triangles, and I guess somewhere along the way it would have some triangles sticking out. 3 rectangles and 2 triangles. That doesn't matter. We know though, if we're trying to find lateral surface area, we're going to leave out 2 parts but find everything else. So the 2 parts we're leaving out are the 2 triangular sides. That means we only need to find the remaining rectangular sides. So that would be, one of them for sure would be this part right here. That's going to be 4 times 10, you can see. 4 times 10 equals 40. Okay, so that's one of them. Let's see what else. We are going to find this the back of the shape. Hopefully me sort of outlining that shows you more clearly. That is going to be 8. It is 8 tall and a width of 10. So 8 times 10, that is 80. And one more. We have one more rectangular side that does not include those two triangles. So I'm highlighting to kind of show you that the front, the slanted front of the shape is also a piece that we need to find. So what lengths do we have? We have a 9 and a 10. So that side is going to be 9 times 10, which is 90. Okay, those are all of the lateral surfaces, leaving out the two triangles. If we included the triangles as well, that would be total surface area. Okay, and so lateral surface area, I can abbreviate that as LSA, is 80 plus 40 plus 90. 80 plus 40 plus 90, that is, okay, 80 plus 40 is 120, plus 90 is 210, right? Yeah, 210 feet. It's still area, so the units are going to be squared. All right, so that's how you would do a lateral surface area question. Okay, example number 2. It's a word problem example. A label is placed around the juice box below, not including the bases. So pay attention to that key phrase right there. They're placing a label just on the sides. Imagine the back of that juice box as well, not including the bases, so not including the top or the bottom. So we need to find just the sides, the area of the side. So let's work on it one at a time. Why don't we find this area right there of the side of the box? That's going to be 4 times 1.5, right, which is 4.1.5, which is 6. Now you would assume that there's also a matching side on what we can't see, but we can picture that there's a matching side just like this, which would also be 6. Okay, what next? What should we tackle next? We just have the front and the back. You see that? Since we're not doing top and bottom, we have the front and the matching back side of the box. So the dimensions for the front are going to be, hang on, that was very messy. So here's the front. The dimensions for the front are a length of 4 right here and a length of 2 right there. So 4 times 2 is 8. And the back, the matching back, would also be 8. So we have 6 and 6 on the left and right. We have 8 and 8 front and back. That's enough for lateral surface area because we excluded the two bases, the top and the bottom. So lateral surface area, all of that put together, 6 plus 6 is 12. 8 plus 8 is 16. That's going to be 28 inches squared. There you go. Again, remember to rewatch these guys. Okay, a triangular prism is covered in a foil label. The label does not cover the two ends. So they're telling us not covering the two ends. The label only covers the remaining sides. So how much foil is necessary to cover this prism? Though they have not used that word lateral surface area, that's what they mean, because then they gave us that hint by telling us that two sides are not covered, right? All right, so let's find the sides that are covered, which would be, this one's very similar to that first example. We definitely need to find that rectangle part. So that's going to be 16.5 times 5. 16.5 times 5 is 82.5. So that's right there. All right, next we need to find, let's see, we do want this back part of the shape. That's going to be 12 by, hang on, let me clean it up to make it obvious. 12 times 16.5. And you have to really be good at seeing through the shape. If you find that seeing through the shape is tricky, guys, don't worry. There's most of the quiz and test questions, all of them actually, are going to be dealing with nets in in 7th grade. So this is still one type of practice, but seeing through the shapes, I understand, can be a little frustrating. Okay, 12 times 16.5 is going to be 198. Okay, two of the sides are done. We have one more, and that's going to be the front of the shape. So the dimensions there are going to be 13 times 16.5. Okay, 13 times 16.5. And that gets us 214.5. Okay, so we have all of the sides that would be included as lateral surface area. Now we just need to add those up to get our answer. 214 plus 198 plus 82.5. The answer is 495 feet squared. There you go. Okay, here's an example of more accurate for a quiz or test, right? You're always going to get a net, and you're going to be asked to find something, either lateral or total surface area, from the net. So these are much easier to visualize. This question says find the lateral surface area. You know what to do. In fact, they've even helped us out here by shading what we do not need. Remember, lateral surface area means, especially on rectangular prisms, take out two of them. If this was folded up, you would take out the top and the bottom, the two bases. Okay, so let's find what we do need. 4.5 times 5, or sorry, 4.2 times 5. 4.2 times 5 is 21. That means, remember, there's always a pair. This other piece right here that looks very similar in size, that is the pair for the 21. Okay, now let's find the other two rectangles. Let's find this one, for example. That one has one of the side lengths of 2.9. This side length would be 5, matching the other 5. So 2.9 times 5 is 14.5. And it has its matching pair, 14.5 over here also. So lateral surface area, which is basically all of the surface area excluding the two bases, is everything added together. 21 plus 21 plus 14.5 plus 14.5 will get us, let's see, 8, 9, 10, 11, 4, 5, 6, 7. Just making sure, hang on. 2 plus 2 is 4, 5, 6, 7, yep. 71. That's going to be centimeters squared. Alrighty, one more. Find the lateral surface area of the prism. Again, they have crossed out and shaded, helped us out by letting us know which ones to cross out. We just need to find everything else. Let's do the easy ones first. 4 times 3 is 12. And here's its match. Okay. 1.5, well, let's see, this length right here is a 4, and this is 1.5, so that's going to be 4 times 1.5, which gets us 4 times 1.5 is 6 and 6 for the match. Okay, so lateral surface area is all of that put together. 12 plus 12 plus 6 plus 6. 12 plus 12 is 24, and the two sixes are 12. So that's going to be 36 feet squared. All right, in conclusion, what you should remember or take from this whole lesson is that lateral surface area, very similar to total. Total is all of the shapes, right? Total would be what you learned yesterday. Total would be every single side in a net or face. Everything added together is total surface area. Lateral surface area is pretty much like total, except for we do not include two of the sides. More specifically, the bases. And sometimes we could say that as top and bottom. So that is lateral surface area. It's always less than the total because obviously two of the sides are missing. Okay, that's the key to today. Total is everything. Lateral is slightly reduced because two of the sides are missing, or maybe just one. Okay, rewatch any of this video if you need to. All of this is preparation for your quiz tomorrow, which is going to go over nets, total surface area, and also lateral surface area, tomorrow's quiz. Okay, message me if you have any questions, and good luck. Bye-bye.